Today I'm going to show you how to prove these questions. Probably you already have watched my other videos. It's exactly the same questions. But why I'm doing this question again? Because I'm going to show you a totally different method. So I'm going to using a polar form instead of exponential form to prove this question. All right, let's start. So question A is same as sum of GP. So I'm going to just write down my formulas. So z plus z squared plus z cubed all the way to zn is equals to z and 1 minus z to the power of n over 1 minus z. This is very easy. It's done. Question B. So instead of writing z equals to ei theta, this time I'm going to let z equals to cis theta. So let z equals to cis theta. So I'm going to put on both left and right of my GP series. Okay. So I will have cis theta plus cis 2 theta plus cis 3 theta plus cis n theta. So will be equals to cis theta 1 minus cis n theta and 1 minus cis theta. To compare to my sentence and the question they asked you to prove, the left-hand side looks like is the imaginary part of every single z. But the right-hand side, we're not sure yet. We can't really see it. So what I'm going to do is I'm going to find my imaginary part of left-hand side and also try to simplify my right-hand side and to see if the imaginary part is the same as the right-hand side of the questions. So let's do the left-hand side first. So the imaginary parts of my left-hand side will become sine theta. Very nice. Sine 2 theta, sine 3 theta, and all the way to sine n theta. So it's very good. That's exactly the left-hand side of my questions. So we got to do the right-hand side. So at the moment, the right-hand side is equals to cis theta and 1 minus cos n theta minus I sine n theta over 1 minus cos theta minus I sine theta. So we got to simplify in the right-hand side. Then we're able to find imaginary parts. So how do we simplify? Since we have 1 minus cos n theta and 1 minus cos theta on both top and bottom, I am going to using double angle formula for cos to simplify the sentence. So I'm just going to recall the double angle formula, see if you still remember. Cos 2 theta is equals to 1 minus 2 sine square theta. So if I rearranging, I will have 2 sine square theta is equals to 1 minus cos 2 theta. So this is the first formula I'm going to using on both numerator and denominator because I have 1 minus cos. And since I changed to the theta into the double angle formulas, so I might have also changed my imaginary part of sine n theta and sine theta. So what's a double angle for the sine theta? I just recall here just for your reference. So sine 2 theta is equals to 2 sine theta cosine theta. So this is another one I'm going to be using in my questions. So both formulas ready here. So let's continue the right hand side. So cis theta keeps there, don't need to worry. So 1 minus cos n theta will become 2 sine square n theta on 2. And the imaginary part become minus 2i sine n theta on 2 and cos n theta on 2. So that's my numerator. And my denominator is the same. I'm going to change to 2 sine square theta on 2 minus 2i sine theta on 2 and cosine theta on 2. Right. So both top and the bottom has 2. I'm going to cutting off the 2's for everywhere to simplify in my sentence, definitely. Okay, and I'm going to also taking the sine n theta on 2 as common factors. Of course, I still have cis theta there, and I have sine n theta on 2 minus cos n theta on 2. So that's my numerator. And my denominator I also have a common factor with sine theta on 2. And left me with sine theta on 2 minus I cos theta on 2. Right. So the both complex number parts are highlighted for you with this part here. Looks like the I is on the wrong positions. I need I on the sine, not on the cos. So if I times I in this sentence, then I will have cos and I sine, which exactly fits in the polar form. And the same with my denominator is also looks like my I is on the wrong positions. If I also times I, then it will give me right polar form. So it looks like I'm going to times I on top and I on bottom, which is very good. It's balanced out. So I just times I on top and I on bottoms. I'm going to just write here in for your inference. Okay, I and I here. So let's continue. So I still have sine and theta on 2 and cis theta. And now this time I have cos and theta on 2 plus I sine and theta on 2 since I times I. And my denominator is going to be also become cos theta on 2 and plus I sine theta on 2. Wow, very nice. Both top and the bottom is just become proper polar form, which I can just write in cis and theta on 2 for the top, and the bottom it just become cis theta on 2. Right. So up to this stage, I have this number in the front. I'm going to just keep that, this and this. And then I all have cis. Some are times, some are divide. So we know when we have the cis form, when we time, we plus the angle. And when we divide, we minus the angle. So then I can simplify my complex number parts. So it becomes cis theta plus n theta all on 2. Right, so this is my right hand side. And then remember, I'm going to find the imaginary part of my right hand side again. So then the number in the front is going to be keep there, sine n theta on 2 and the sine theta on 2. And the cis, I'm going to just write in the sine because I'm finding the imaginary part. So that become 1 plus n on 2 theta. So that's exactly same as the right hand side of my questions. As you can see, I'll go to the front. So we're done.